Today's lesson is section 1.5 in your pre-calculus books, and the lesson is a library of functions. And as we begin, we're here and we're looking at a linear function. Again, nothing new. We've studied linear equations for a very long time. And we know that if it's linear, that means it's going to be a line. And every linear equation is going to look like a line. Okay, so again with functions it's no different. Every linear function is simply going to be a function whose graph is the graph of a line. Well, we also can see that every squaring function or quadratic function, and that's a function that has an f of x equals x squared, is going to be a parabola. Everyone is going to be a parabola. And we will learn in tomorrow's lesson what happens when we add negative signs and we add values, and negative x squared would simply be opening down. And so we get this picture. When I took this, we called it a family of functions. And we called this the parent function because this was f of x equals x squared. The line that we just saw was f of x equals x. In other words, the y value and the x value are always going to be the same, 2, 2, 3, 3. Y equals x if it was a linear equation. Now we describe it as a linear function, and the function of x at 2 is 2. The function of x at 5 is 5. Okay, so just not different language again. Now, when we look at f of x equals x cubed, if we look at the one side of it, it looks very much like the parabola. Whose negative side is flipped over. Well, this is because when we cube our negative x values, we get a negative answer. When you square negative 1, you get positive 1. When you square negative 2, you get positive 4. But when you cube negative 1, you have 3 negatives in your multiplication, and so it's turning down instead of up because of this odd numbered power. It's giving us an odd number of negative signs. Negative 1 times negative 1 times negative 1 is going to be negative 1. The same negative 2 times negative 2 is positive 4, times negative 2 again is negative 8. Okay, and so this is why we're always, every cubed function, every cubic function, every third degree is going to look like this. We will learn again in upcoming lessons how to move that around, but for right now we're looking at the parent function, f of x equals x cubed, and the parent function goes through the origin. The parent function always goes through the origin. So look again at x squared. You see it goes through the origin. Look at y equals x, or f of x equals x, through the origin. Let's look at the absolute value function. Here we have, again, the origin. The absolute value function is always this v. So this would be f of x equals the absolute value of x. And simply the absolute value of 0 is 0, the absolute value of 1 is 1, the absolute value of 2 is 2, absolute value of negative 1 is positive 1, Absolute value of negative 1/3 is 1/3. Negative or positive 3/4, it's 3/4. And so we get this graph of a v. And every absolute value function will have a graph that looks like this v. We might multiply this by some number, which will simply make the v a lot narrower because it's going to go up faster. 3 times the absolute value of 1 is 3. And we'll learn tomorrow about that. But today we want to focus on learning to identify the shapes of the graphs. So the absolute value graph. The next one we're going to look at is the square root function. And there it is. Now, interesting, the square root function, if we turn this whole graph sideways, there's your half of a parabola again. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. And you can see this line would be heading towards to intersect the 3 when x is 9. And so, again, this is f of x equals the square root of x. That's another parent function. That's the parent of something like this. F of x equals the square root of 2x, or the square root of x minus 7, or 3 times the square root of 2x. Get the idea. This is the parent. This is the one through the origin. We have the cube root function. Similar to the square root function, but notice we have a negative side. And if we remember our domain and our range, we can see that the domain is going to be all real numbers for the cube function. And it's going to be all real numbers for the range as well. You go back and look at the square root function. The domain is x such that x is greater than or equal to 0. There are no negatives allowed under your square root sign. Can't have a negative under your radicand. You look at your absolute value. The domain is all real numbers. But the range is everything y that's greater than or equal to 0. Going on to the last function, and it is called the piecewise function. And I am going to draw it on this graph, so please ignore the graph that's already there. I don't have the technology to eliminate that blue line, but the piecewise function is a function that has different pieces in it. This one is called the greatest integer function. Greatest integer function. So if you see something like that, this is called a step function. That's the broader category, step function. And this specific step function is called the greatest integer. Okay, so what that means is that if you had, let's say I gave you f of x equals the greatest integer. Well, 1.5. The greatest integer, 1.5, is 1. 1 and 7/8. It's still 1. 1 and 99/100. It's still 1. The integer part is it's just 1. It goes negative as well. Greatest integer, -1, -1.5 is actually backwards here. Greatest integer is always the one before it. Once you get to 3, the greatest integer is 3 now. Anyway, we won't look at this a lot. This is just an interesting function at this level of math. And if you have questions about it, be glad to talk about this in class. Again, step functions. We have piecewise functions. Piecewise. This is a function that's given with restrictions. So f of x may equal 3x plus 2 for x is greater than or equal to 0, and it might equal x squared for x less than 0. See, we give you conditions. We say if x is bigger than this, then this is what it is. So we'd go up here to 2, we'd go up 3 over 1. Since that's greater than or equal to 0, it's a solid dot, but here we see that less than 0, x squared. And so we'd have to come here, because this isn't including the 0, we put that open circle, and this side would be our parabola. And so the red here would be the graph of this piecewise function, ignoring that blue absolute value function. So it's simply, it's one function on one side of this number, and it's just another function on the other side. No better way to explain that. So anyway, that is what the family of, or library of functions are, is memorizing, when you see the graph, what the graph is. And you'll have noticed we have odd and even powers of f. In other words, we have f of x equals x squared. That's an even power. F of x equals x to the 4th. F of x equals x to the 6th. These are all even functions. Even functions. And on an even function, you notice that the graph will be symmetric about this line of symmetry that goes down the center. It's the same. They're mirror images on both sides. X squared. Mirror image. X to the 4th is going to look a lot like x squared. X to the 6th is going to look a lot like that. We'll get into that in more detail in upcoming lessons. And then we have odd functions. Odd functions are the ones where the symmetry doesn't happen about this axis, but instead it changes here. And what we get is the condition that x to the 5th, we get is the condition that if you put in f of negative x, if you change the value negative, you're going to get out negative f of x. In other words, look, here's f of 1. If we put in f of negative 1, we're going to get out the negative of what we got out here. And so it kind of reflects it down. It's not really a reflection. So this is the formal definition of an odd function. So if you put in a negative value of x, like for instance, f of x equals x to the 3rd, and we know that f of 2, let me erase this a little bit and do it over here. We know that if we had f of x equals x to the 3rd, f of 2 equals 8, 2 to the 3rd. F of negative 2 then is going to equal negative 8. F of negative x equals negative f of x. Anyway, thank you for your time, attention, and attendance.